Okay, so let's talk about the course that I'm offering this spring 2020, the Smart Material Structure. This course is offered every spring semester, and this contributes to our lab, the Humanoid Biorobotics and Smart Systems HBS lab. So one of the important course in order to demonstrate novel designs. So this course is associated with design and innovation because these intelligent material or smart materials enable a system to attain intelligence. So let me briefly talk about the course. So we'll introduce, as you see here, it's about introduction to smart material, the basics of smart materials. We will see the fundamental properties of these materials, including shape media alloy, piezoelectric materials, um, conductive polymers, dielectric elastomer, ionic polymer, metal composites. These are the four uh, types of materials that we mainly focus. We'll look at other materials like conductive polymer as well. More importantly, if we know materials, if we know something, we can describe it mathematically. So we can describe the equations for it. We can explain it. So we will study the constitutive modeling of this smart material, how their behavior is governed by certain equations. Also, we will characterize this, we will study the characterization technique for this material, for this special class of material. Um, and finally, we will have applications. We will look at the applications as a sensor, actuator, or energy harvesting system. Okay, so let's take a look at this material. This figure explain uh, the different material easily. Look at the first one is piezoelectric. Piezoelectric material, when you apply stress in the material, it deform, and when it deform, it generates charge on the surface. When you connect to a certain oscilloscope, you will see a change in voltage. Basically, it's a ceramic disc. This is a disc, and there is the top and the bottom. There is a metal plate. It could be coating or it could be metallic. Okay, that's the basics. So when you apply stress in the material, they generate voltage, as you see briefly. Okay, this is called piezoelectric material. We'll study about this material more. If you look at this material, this is another form of piezoelectric composite. This composite material, the one that you see in the orange color, is bonded into this steel plate, and the plate is metallic. So when you apply voltage, this is a power supply. When voltage is applied to it, this start bending. Okay, so now it's operating as an actuator. The piezoelectric material is operating as an actuator. In this case, it's operating as a sensor. When you apply force, it generates voltage. So two aspects of piezoelectric that we are looking: the sensing, actuation. In other words, when you apply force and generating voltage, this will lead to energy harvesting as well. Okay, we'll talk about those in this class. And what you see here is that we'll describe the properties of this piezoelectric material using constitutive modeling. Okay, this is based on what you know before. Okay, for example, this S is a strain, this is compliance, inverse of modulus, stress, T is stress, D is piezoelectric coefficient, and E is electric field. Okay, so we add this term in the piezoelectric material to define constitutive equation. And this is electric displacement, and this is stress, this is electric field, permittivity, and piezoelectric constant. So this describes constitutive equation of piezoelectric. We'll come to this in detail in this class. Okay. The other one, very interesting material, is the shape Mary alloy. As you see here, this material, when you deform it and put it into a hot water, it will regain its shape. So it remembers its original shape when it's subjected to heat. No matter what deformation is applied in the material, when you heat it, it deforms back to its shape. Very interesting material. So that's called shape memory alloy, SMA. So we'll study in this class the behavior of this material, the compositions, the properties, and the governing equation. I will not go in detail about it. All right. The other one is called dielectric elastomer, DE. This one is elastomeric material. It can stretch more than 100% of its original shape. But this material has another structure. There is a coating from the top and the bottom. The black color that you see is a carbon black coating. The coating is applied on the surface, and when you apply electric voltage, usually huge voltage in the terminal from the top and the bottom, this material will deform. It will exhibit large deformation, very large deformation compared to the piezoelectric. Okay, that's called dielectric elastomer. The other one is called ionic polymer composite, ionic metal composite, or IPMC. As you see here, this is used as an actuator. When you supply voltage into the material, they deform. Okay, it's a sandwiched composite material, uh, special material in between, which we will discuss in detail about this material. So that's one kind of material. Regarding application domain, it's used in the healthcare, robotics, energy, defense, aerospace, and also in the auto industry. All this material, there are tons of application for this. And we'll use this textbook by Don Leo for most of the understanding of this material along with homework. So I suggest reading this textbook. Okay, that's a brief introduction to smart material for this class.